got lots of work done. I'm hoping. As you know, your week 1 turn-in is this week. It's actually this evening by midnight, so make sure you get that uploaded properly. Again, in terms of words of advice, make sure you're reading the activity, because there's hints in there to tell you what you're supposed to be doing. Make sure you're using your self-grade document to double-check what we're asking for versus what you're turning in. And remember that you only need one self-grade document for the entire month, because every week is on that same document. There's just a different tab for each week. So make sure you're clicking on those and you get to the right week with the first one, which is where it should default when you open it. Also, please, I can't beg you enough, watch that turn-in procedure video. You really have to watch that. That's not like an optional, if you feel like it thing. It literally breaks down exactly how you have to turn stuff in. So make sure you're looking at that for the procedure, but do read FSO for the written instructions on how to execute that turn-in. So you do have to use both of those things. And FSO is always the final word on what stuff is supposed to look like. So make sure you're using that as your all-encompassing guide. In terms of what's being turned in, you're going to be blocking out some objects, and that's going to be kind of like what we did for our skill check number 2, creating simple primitives and moving them into place to kind of occupy the shape and the form of the object in the image planes. In terms of a blockout, you can change the shape of the geometry using any of the tools you want. You can manipulate the components a little bit if you want to. That's totally fine. The only thing you can't do in a blockout is use your big 3 tools. So make sure you're not modeling. If you're using insert edge loop tool, extrude tool, or multicut, you're using one of the big 3, and that's not a blockout. Conversely, we are turning in, as a practice, 2 models that we're actually modeling the way we should model it, using things like build it like it was built as a guide. We're going to be using the big 3 tools for that, insert edge loop, multicut, and extrude. So that's going to be a good guide for you in terms of how next week's turn-in is going to go. So do your best to get this one done. You'll get some good feedback on it, and then that will help you tremendously with the following week, and that's what we're always trying to do here. So again, use all that information we've given you because it's out there, and it will make a difference. Any questions on that? Yeah, go ahead. The big 3 on a blockout. Oh, sure. If you want to move the vertices for your blockout, that's totally fine. I'm not adverse to that in the least. That'll only make you better at manipulating components, that's modeling, straight up. But what I don't want you to do is add components and using those big 3 tools in order to change the shape of an object. Does that make sense? They're 2 different skill sets, and I want to make sure we can do both. So that's a great question. Are there any other questions in terms of that first turn-in that's tonight? Please don't wait till 11:59 to try to submit it. The whole school is trying to submit at 11:59. The tube that the information goes through is only so big, so don't do that. It'll choke. My personal advice on turn-ins, about an hour before something's due, just stop working. Start saving up, start naming, get your self-grade out. Don't work right up till the very last minute, because as you and I both know, what it looks like is only 1/3 of the grade. So if you work right up to 11:59 making it look pretty, and then you rush through the technicals, you're gonna miss those, and then that's 2/3 of the points. So don't do that. An hour before, stop, go through the self-grade, make sure you're doing the things you need to do, double check your work, start the upload process because it's not instantaneous. Even technology has its limits, believe it or not. So you got to be smart about that turn-in. Make sense? Hell yeah, oh, thank you for playing. My digital friends, does that make sense for you guys? You got it?
Matthew says yes.
Awesome. Well, as long as Matthew's on board, we're good. Because he's going to tell everyone else. Whoa! Jonathan. All right. So let's get to today's material. Last time we talked, we spoke a little bit about, in terms of modeling, we'd like the faces on our geometry to have 4 sides. For the entirety of the object, if at all possible. 3 sides is okay, triangles are fine, but what we don't want are n-gons. So today what we're going to talk about is looking for and fixing geometry issues, because not only are we artists and modelers, we also have to be doctors to a certain degree. We have to fix problem geometry. Now the good news is, if you model the way we've taught you, you're going to have an extreme minimum of these problems, but these problems do come up, and especially if you get hired to fix somebody else's geometry, because that happens. That's a thing. Companies will be looking to hire somebody, and they're looking for the lowest bidder when it comes to building something, and they'll hire somebody who gives them a rock bottom price, but they get really poor quality geometry that just doesn't work at all, and they will literally hire you to fix it and make it better. So what we have to learn how to do is troubleshoot problem geometry. I'm going to help you identify where these problems are and how to fix them. And again, think of yourself like a polygon doctor. So we're going to make the geometry feel all better. So what we're going to do is I'm going to break down for you a big collection of illnesses, as it were, jot down those illnesses and the fixes for them. There are more than a few, so you're going to need to have more than one answer there. And then we're going to go do a test where we're going to try to find and fix problem geometry, because that is, again, a big part of our job as a modeler, is to create. Actually, it doesn't matter whether we're modeling it anywhere in the pipeline. We're trying to create assets that don't hinder the flow of the CG production pipeline. So everything we're trying to do is to help facilitate the fluid and easy transmission of our artwork to the next station on that line. So without further ado, we're going to get into, again, polygon illnesses, how to fix them, and we're going to get into the cleanup tool. Help me find these problems, because I don't want to go looking for them all. Help me, Maya, do something that machines are great at: find problems, in addition to creating them on occasion. I kid technology. I'm so sorry. All right, so let's get to it. Alrighty, so I am logged in, and I'm going to go hit my magic share my screen button. So I am now sharing. Is that right? My digital friends, you see, I didn't screw it up today. Every dog has, I was practicing all weekend to try to get that right. All right, here we go. Let's talk about, oh, incidentally, as a little side note today, for some reason the top two rows of my keyboard aren't working intermittently. So sometimes when I type stuff, some of the letters don't show up. So I apologize in advance if anything weird happens. And also, for those of you at home, if you get an email from me that doesn't make any sense, that's the problem. I don't have all my keys working. Time to go see the boss about getting a new laptop. All right, so here we go, lecture 4. First thing we're going to talk about is levels of detail. Just like with illustration, when we're modeling, we start with very simple, and then we work our way towards more complex. And we move a little bit at a time, adding detail a little bit with each pass. So for example, when we're just starting to draw something, we start with the simple primitive shapes and volumes that represent the object we're trying to create. Again, very primitive. We've just got some basic shape and form in there, line of action, that kind of thing. And what we're talking about and setting up in this instance in terms of an illustration, same thing as a model. Our first couple of steps, our primitive build or block out, what we're doing is creating our primary forms. So when we first start modeling, we first start creating those volumes and those shapes that we see when we're trying to recreate an object. They are the primary forms. Then we go to our next level of detail, and we call these the secondary forms. And secondary forms are basically where we start connecting aspects of our primary details to each other. We're creating those transition areas. It's sort of a finer level of detail. And you can see we just start at the top of the model and work our way down, or start at the bottom and work our way up, and we add another level of detail. Then we get into what we call the tertiary forms, and that's where we're getting into the very fine details of an object that really identify the object for what it is and really make it look real. So, you know, in terms of an illustration, putting little wrinkles and creases and some fine surface details in there, that really sells it as the object it is supposed to be. And for our models, the same thing holds true. Little tiny details that make the object look real. Little screws, little scratches on the surface, marks on it that would make this object look separate from a box full of the same object. These are our tertiary forms, and again, represent the finest level of detail on our modeling and the last stage of both modeling and illustration. But they work the same. In fact, there are a lot of parallels between illustration and modeling. I'm hoping you're starting to see those things. In fact, to be perfectly honest with you, when it comes to 3D, all of 3D is very heavily steeped in traditional art values and strategies. So good idea, if you do any traditional art, stay with that stuff. It'll really help you. And if you don't do traditional art, there's no reason why you can't start getting into it. Things like illustration, those are skills you can learn to do. You don't have to be magically born with the ability to draw. You can learn to do that. So I very highly recommend you keep with those things, no matter what it is you choose to do. Picture's worth 1,000 words. That is not just a saying. It's very helpful if you can draw, particularly if you're in a big meeting and you're trying to communicate your ideas to a group. It's nice to be able to stand up and at least be able to sketch out what it is you're talking about loosely. Again, greater understanding by the masses, always to your advantage. So again, modeling primary, secondary, and tertiary forms. These are sort of the different levels of detail. Again, you start simple, and then with each pass, you add detail. Illustration and modeling, the same there. Any questions about levels of detail? Does that make sense? Yeah, go ahead.
What would be the appropriate level to add details to the face? Would that be in the secondary form, or
To add, I'm sorry?
add like face details, like eyes, wrinkles?
Okay, so the question is in terms of face details.
Secondary form or the
Tertiary form. Well, in terms of basic forms of the face, you're probably going to start adding details like nostrils and eyes and mouth and that kind of thing as a secondary form. Your primary forms are going to be mostly the shape of the head, trying to get the jaw right, get the neck proportioned properly relative to the head. But your secondary details, that's where you're going to start fleshing out, if you excuse the pun, the eyes and the nose and that kind of thing. But even then, that's not the finest level of detail for the face, because you still have to get in and create those subtle transitions, like from the cheekbone to the nasolabial fold and how that transitions onto the surface of the mouth. So there are a lot of details, and you can get into them, again, gently. You don't want to go too strong right away, because if you're drawing all the creases of your face and you haven't even worked out the relative proportion of the parts of your face, that's where your drawing starts to get away from you, and it can start to look like an abstract illustration. Does that make sense?
Yeah.
Same thing happens with modeling. If you start too fine right away, you realize your proportions are lost, and that's why we start with the broad strokes and work our way in. Does that make sense? That's a terrific question, though. How many of you guys are excited he asked that question? Yeah? Brian is really excited. And honestly, that's why I like to think of questions as bonus information. I would have never gone into that had he not asked. So all of you guys got a little bit of extra something. All right, so let's do a little vocabulary, because I love to do that. Vocabulary. Edge looping and topology. Edge looping and topology is the way we talk about how the edges flow across the surface of geometry. It's one thing to have nice shape and form, but the technical side of it, and again, showing the level of mastery that you have for modeling, is evident in your edge looping and your topology. And again, we're always trying to be efficient with our modeling, neat and clean with our modeling. I'd like you to think of edge looping and topology almost like the supporting structures of the object. Like if you take a building and you remove its surface, you see all the girders. And those nice, neat, clean, very tightly organized girders create the structure of the building, whatever it happens to be. So edge looping does pretty much the same thing. It's the girders that support the form and shape of the object. So having neat and clean edge looping is terrific. So make sure you got that going on. In terms of examples of neat and clean edge looping and topology, if you take a look, you can see this is a very neat and organized set of models in terms of the edge looping up here. It looks very professional, very neat and clean, efficient and organized. If you look down here at this image, you can see that the edge looping is somewhat irregular. There's some unusual shading in there, which is Maya's way of telling you you're doing something naughty. And it just, in looking at it, you would deduce that the individual who built this would be a little bit more competent than the individual who built this. Does that make sense? So when we're talking about edge looping and topology, we want to see much more of this and much less of that. Now, that's not to say that some details may require some unusual edge looping, because that happens on occasion. You'll be building something that's really kind of challenging to build, and it might get a little bit messy, but you try to keep it as neat and clean as you can. Does that make sense? Edge looping and topology? Okay. All right, good, good, good. And again, anything that I tell you, you know that's something you're going to be responsible for. Not necessarily for your block out, but do you think this is something you would lose points on for your models? Oh, yes, definitely. So keep track of that, these little terms and things I throw at you, because you know that's stuff you're being graded on for sure. I don't mention things that you won't be responsible for. All right. Another fun little thing here is let's talk a little bit about edge. No, yeah, all right, we'll talk about edge quality. In terms of edge quality, because this is kind of an abstract thought initially. In terms of edge quality, what we're trying to communicate is that objects have sort of a personality or a character to them. And that personality or character is evident in the design, the shape and the form of the object. In particular, where surfaces come together, those transitions from one point to another, Gesundheit. For example, if you look at a toy, you can tell what toys are made for older kids versus what toys are made for younger kids. The toys that are made for younger kids are more rounded and soft. There's not really those pointy, sharp things on there. It's not quite as detailed. It has a more fun, playful, it probably has big eyes and a smile on it, right? Versus toys that are made for older kids look a little bit more realistic. They'll have harder edges on it. Does that make sense? Okay, so in terms of edge quality, what we're talking about is how those surfaces come together and how they transition. Quality of edge, which is very highly evident as soon as you start lighting things. But let's talk a little bit more about those ideas. The personality and the character of an object. Now, here's an example of a car that was built in the 50s. It's a Cadillac. If you look at the car and you look at all of the transitions that take place on the surface of that car, you can see that the whole car exhibits, again, a personality or a character. How these surfaces come together, these rounded areas. Doesn't matter where you look on the car, there's definitely sort of this fun, happy sort of look and feel to the car. And you can really see the transitions where the shadows meet the highlights. And again, this is a car that was built in the 50s, sort of a happier, more positive era. You know, World War II is over, the economy in the U.S. is booming, everybody's, you know, feeling pretty good about themselves. Elvis, of course, how can you go wrong with that? Well, anyway, so the point is, in terms of that time, there's definitely a feel. And there's a look to the cars of that era. And again, it's the design or the character of the car that comes out. If you saw a car made by another car company that was made in the 50s, you would say, oh, that car was made in the 50s for sure, I recognize it, because of those changes in shape, those the quality of the edge and the transition between those surfaces. You could identify it as a car that was made in the 50s. All right? Now, in contrast to that, here's another Cadillac, but this one was made in the 70s. Different era in human history. Definitely, if you look at the vehicle, drastically different in terms of the edge quality. You can see the edges are a lot harder here. The transitions from highlight to shadow on these surfaces is much stronger. It represents a harder and edgier time in American history in terms of when this car was built. And again, if you look, the quality of edge, you see that everywhere in this vehicle. Much harder, much crisper, totally different look and feel different character or personality to this car. Similarly, if you look at other cars that were made in the 70s, they have a lot of those same design qualities to them. You could pick that out. That's a car that was made in the 70s. Does that make sense? Okay, so we're talking about the quality of edge and how surfaces come together. In fact, if you take a look at the desk that you're sitting at right now, you can see the top of the desk and the side of the desk comes together at what you would believe to be a 90-degree angle, right? But the reality of the situation is if you look at that corner where those two edges or those two surfaces meet, it doesn't come together at a crisp, sharp 90-degree angle. There's a tiny bit of rounding there that takes place. Does that make sense? It's very subtle, it's very small, but that rounding is important that you build into the shape of your objects. You've probably noticed when you're playing video games, some assets, models look sort of gamey because when they come together, those surfaces, it's at a 90-degree angle. Everything looks very hard and sharp. Again, reminiscent of this kind of look, very gamey in design. Well, that's because those assets, they can't afford to have enough polygons to kind of round the corners a little bit and make it a little bit softer. So as a result, that has, again, a look to it. It's totally different from what you would see in a movie or a high-end game, your Xbox 360 and the like. So a lot of times, limits of the polygons can sort of create a look to things. But what we're going for in this class is we want to build things like they're really built. So if you take a look at an object and you're looking at the edges here, and you can see, roll my little desk out here, again, these two surfaces come together at 90 degrees, but there's a little bit of rounding there, right? I can't cut myself on that edge. There's a little bit on there. And that's what we want to do is make sure that when we're modeling, we're thinking about how these surfaces come together and what kind of rounding we need to make that look realistic. Does that make sense? That's edge quality. All right. Now, the good news is we can do this with modeling tools. I can use the extrude tool. I can use the insert edge loop tool. You know, those are great fun tools. But the truth of the matter is we have a tool called the bevel tool, which is super easy to use, lots of fun, and it creates nice rounding of the corners on things. I'd like you to think of the bevel tool as almost like sandpaper. It gives you the ability to just kind of wear things down a little bit on its edges to make it look a little bit more reasonable. All right. Now, you guys ready to play with the bevel tool a little bit? Hell yeah. There we go. There's a marginal enthusiasm. Let's do it. All right. So, let me get my copy of Maya out and running. Here we go. All right. Now, oh, I don't want to make it too big. Make sure my online friends can see it. So I'm going to go to File and Set Project because that's the first thing I always do. And I'm going to go to my 3DF folder and choose my activity file folder and set it to that. And then go to File, Open Scene, and I want my bevel tool activity. So make sure you choose that one and hit all the OKs that pop up. All right. Now, in the bevel tool activity, you'll see I've got these three pieces of geometry. Two of them are pretty straightforward. One of them is totally banana. And these things we're going to learn how to use the bevel tool on. Now, as I said before, the bevel tool kind of works like sandpaper. It rounds the corners of things a little bit. So as you would imagine, this tool works on edges. So what we want to do is go to Edge Mode, and you're going to want to select edges. And in terms of our edge selection, you'll notice I'm grabbing edges where I've got sharp transitions. Like, for example, you can see that the surface of this object is very curved on the side. I'm not going to grab these edges and try to bevel them. There's no point. It's already smooth and curved. Does that make sense? So what I'm going to do instead is grab this object, and again, I'm going to grab the edges across where I have a transition here, a pretty severe one. And I'm going to go to Edit Mesh, and then right up here you will see bevel. And one of the fun things about the bevel tool is this is one of those tools that has sort of an interactive dialog box where I can make adjustments to my beveling even after I did it, so I can kind of make sure I'm getting the look I want. So the things that we're going to be playing with is, number one, fraction. And fraction is basically saying, well, how much of the corner am I sanding off? So if you take your cursor and put it over the word fraction, and then hold down your left mouse button and move it left or right, you will see you can take off more or less of the corner. So you can make a little interactive adjustment there. The next category down is segments. And what segments is doing is putting divisions in between that area you just sanded. And the more of them you plug in, obviously the smoother the transition, fewer segments, you get harder, more angular transitions. So again, depending on the look you're going for, you can make an adjustment to that. And then the last thing we're going to mess with here is the depth. And in terms of depth, you'll notice it defaults to 1, and it sort of bubbles out a little bit there. Well, you can actually, again, with the left mouse button, drag left and right and sort of make that less aggressive and kind of take that outward bowing of the geometry and bring it in. And if you go into negative values, you can literally reverse it and make sort of like a Pizza Hut looking roof to the top of this piece of geometry. Now, in terms of objects, again, what you want to do is work it on edges. And so, for example, if you look at this object and you just look at how the shade meets the light here, you can see that's a very hard transition in terms of that the lighting showing off that hard transition from this surface to this surface. So what I'm going to do is grab an edge, and I could hold shift and keep adding to my selection, or if I click and then double click on it, it'll grab a whole edge loop, and you see that's kind of faster. So I'll just double click on that, and then again, under Edit Mesh, I'm going to go to Bevel, and let me ease up on that fraction and add a couple of segments in there. And if you take a look, now it's a much more subtle transition around the edge of that surface there. You can see how the light is, and this is very primitive lighting, and I can already see how that is changing the behavior of these things. And you can bevel both the inside and the outside of the object. And, oh, I don't know, maybe make something that looks like a bottleneck. Anyway, so what I'd like you to do is start thinking about those edges and how they meet each other on the real object and try to match that transition. Is it big and bubbly like that, or is it a little bit harder, or is it a lot harder? So take a look at those objects closely when you're looking at them. And then, of course, I gave you this totally bizarre shape just so you could see how they worked out in terms of its behavior. And something you've got to be aware of is the bevel tool will create kind of messy geometry. So you have to sort of take that into account when you're using the tool, because yes, it will give you that nice rounding, but will it create illegal geometry? Oh, definitely. So when you use that bevel tool, make sure you're going back in and taking a look at what it did. And, you know, do I need to fix my edge looping as a result of using it? But again, this looks very gamey until I grab all of those edges and then run the bevel tool on it. And now that looks kind of cool. Does that make sense? So Brian and I walk around a little bit and see what you guys are doing. Make sure you've got a handle on the bevel tool. It's a pretty easy tool to use, so I think you'll like it just on that level alone. But it works pretty well.
I noticed it can work on Facebook, just not clips.
Yeah, exactly. It's much more useful on edges. And you'll find that there's a lot of tools in Maya that can be used in different ways than they were designed for, and that's not necessarily a bad thing. If you figure something out, you know, awesome, good for you. But understanding what it's doing and the price you'll pay for some of the craziness that it does, that's the important part. But yeah, experiment. You don't know what the tool can do until you try it. And to be honest with you, I would much rather you guys played. I mean, you can't just take the little bit that I give you as all that tool can do. You got to play with it and explore and see what it can do. And that's why I gave you guys these files to work with, because, you know, who cares what it does to this stuff, right? This is just practice geometry. You can beat this up and it doesn't make any difference. There you go. And you can see it creates really woolly edge looping if you just kind of select one edge here and one edge there. But if you grab several edges at a time and do it, it has a tendency to create better looking geometry. In terms of the edge looping and topology. Woo!
You know, like a render view?
What's that?
Like a render view?
Oh yeah, well we're going to talk about that, but there's an icon up on the main interface that you can press for that. But you want to make sure you've got the right rendering engine in there in order to actually see what it's doing. Because depending on what it's set for by default, you might not see what it's going to look like in a final actual render versus a rough draft kind of render. Does that make sense?
Yeah.
Good, good. Nice. Looks like you guys are doing pretty well with this. How are we doing? Do you guys love the bevel tool yet? Yeah, super helpful. Very fast and easy way to make things look more realistic. And that's what we're going for here, is we're trying to build stuff that looks like the real thing. And incidentally, back row, I'm not ignoring anybody back there. My headset sometimes drops out when I go too far that way. We've had that happen a couple times. I'm not allowed in the back row. So Brian will get back there and make sure you guys are all right. All right, what do you guys think? Not a bad tool? Pretty fun and easy. Minimal complexity on there. So, all right, cool. Let's get back in there and talk about some more fun stuff. Again, keep an eye on that, the quads and what have you. All right, so clean geometry. We alluded to this last class. I talked a little bit about it. You know, I talk about it here and there and how important it is. Clean geometry is the idea that we're trying to keep our geometry in a situation where it's mostly quadded. So most of the faces have 4 sides. Some triangles okay here and there. And again, this is regard to this class. In other instances, it might be, it's got to be all triangles. In another class, it might be everything has to have all 4 sides. So you do have to pay attention to these rules as they vary. But more than 4 sides is commonly referred to as an n-gon, and that's never good. And that doesn't matter what class you're in. That causes problems. So we're always trying to make sure we don't have any of that stuff going on. But what we're going to do is we're going to talk about using Maya as a tool to help us find problem geometry. Because, again, it's pretty easy when you're looking at a cube and you go, oh, that side has 4 faces, that side's only got 3, that's the problem. Or this one's got 9 sides, obviously that's got to be fixed. But if you're looking at a very big, complex object with a lot of detail on it, ooh, all right, so how do I figure out where my problems are? And here's where we can use Maya and the cleanup tool to help us find problems, and then we fix them. So clean geometry, again, our goal is to create mathematically sound geometry that will not have issues in our CG production pipeline or in other applications if we bring our geometry in there. Again, crazy things happen, so I'm going to give you a big long list so that you can be educated polygon doctors and then be able to find these problems, and then you know the fixes for them. In terms of these fixes, we'll talk more about how to use the tool, but first the illnesses. All right, unsupported vertices. Unsupported vertices is an issue that typically comes up with early modelers when they create a detail that they need and they see additional edges and they're like, well, I can delete these and they don't affect my model any, so I should delete them. But the truth of the matter is you still need those edges. For example, here's that same modeling detail, but what you can see is these vertices are all connected to each other. Those are supported. That's what you want. Everything fully structured and connected. In this instance here, these vertices actually can accidentally be deleted and it will change the shape of the object. And what makes matters worse is this is a big 8-sided face. So that's definitely an n-gon. There are issues there. These vertices are not properly connected to one another and therefore not properly, not mathematically sound. So we definitely want to make sure we don't have any unsupported vertices. All right, non-planar faces. Non-planar faces is the idea that I'd like you to think of the faces on your model like a big piece of paper. And what you would like ideally is for your faces to be the vertices in the same plane. And you know, a little bit of torsion is okay, it's not a huge deal. But what you don't want to have happen is to have one of those vertices dip way out of a line with the other ones to where I'm causing a change in the shape of the face, a dramatic one, to the point where there's a big bend, but there's no edge to support that bend. You see how this is bending, and you would think there would need to be an edge there to support that bend? Okay, but there's not. So what I would see here is just that gray surface area. And again, if you have to twist a face, you know, to some unrecognizable shape to hit a detail, you're trying to push this one face too much. You need more geometry in that area to attain that detail. Does that make sense? So you want to try to keep it as close to flat. Again, a little bit of torsion is okay, but you don't want to have excessive amounts of it, particularly if you're dealing with organic shape and form, meaning whether it's flesh or something that will change shape somewhat, because that bad geometry, when it bends and moves, will come apart on you, and it looks really terrible. So again, try to keep those guys nice and flat. Think of it like a piece of paper, and you want to keep those guys together. And again, this is called non-planar faces. Okay, lamina faces. Some of you guys might have seen this already because we've started using the extrude tool. Anytime you get that crazy black shaded pattern here, this moire pattern, this is Maya's way of telling you that something's wrong with your geometry. And the lamina faces is the idea that you've got two faces directly on top of each other, and Maya is not even sure how to shade that geometry. Now, this is kind of an obscure thought, but let's, I want to show you something in Maya. When I'm in Maya, where are you, Maya? There you are. When I'm in Maya, some faces get shadow, some faces get light, some faces get a highlight as the light sort of careens off of the surface. Is there really light inside of Maya? No, not really, but there's a mathematical algorithm or formula that figures out, well, if light is shining on this piece of geometry, this one gets light and this one gets shadow because of the angle of the light relative to the geometry. Does that make sense? Okay, so in terms of Maya, how does Maya figure that out? Well, we've talked about vertices, edges, and faces, right, in terms of polygon components. Well, there's another component of a polygon object. It's called the normal. And the normal is basically almost like a thermometer reads temperature. The normal reads light. So if a face of the geometry is facing towards a light, the normal tells Maya, hey, my face is at this and such angle to the light and therefore should receive light. Versus another face, which would be pointing a different direction, the normal would say, I'm not getting any of that light because my face is angled away from that light. So therefore, I should be in shadow. Does that make sense? Okay, so the issue we run into with lamina faces is if I've got two faces directly on top of each other, which one gets light and which one gets shadow? I can't figure it out because every face has a normal on it, but they don't know how to light. Does that make sense? Okay, so typically what you do in those scenarios is you either have to space it a little bit or you literally have to delete one of those faces because they're on top of each other. Just kind of clear it out. Think of every face on your polygon object almost like a leaf on a plant. They all have to be out and open to the air to receive sunlight. So they should not be hidden. All right. All right, so again, this is what it looks like, lamina faces. Non-manifold geometry comes in 3 varieties. And basically, again, it leads to mathematically unsound geometry is the problem. But in terms of non-manifold geometry, 3 faces sharing the same edge. So if you look at this edge right here, you can see there's 1 face, 2 faces, 3 faces, and they're all sharing that same edge. Now, it's true there could be an object that had that kind of detail on it, but whatever this piece would happen to be, it would need to be thicker than a single face. You know, again, unless it's a piece of paper, we don't model it paper thin. So with that added level of thickness, there would be a little edge loop that would connect over here, and then those 3 faces would not be sharing the same edge. There'd be a separate face in there. So again, things that we're trying to avoid, unnatural occurrences like 3 faces sharing the same edge. Similarly, you can't have 2 faces connected by a single vertice. So if you're looking at this object, whatever it happens to be, the vertice is an infinitely small object. So there's no way these 2 faces could be connected to each other by just 1 vertice. Again, that would be like attaching your arm to your body by 1 molecule. You know, it just doesn't happen. There's got to be a little bit more to the connection between faces. So at least 2 vertices have to be connecting to each other to avoid non-manifold geometry. And then the third form of non-manifold geometry are faces with opposite normals. Remember, we were just talking about normals, those little posts that stick out of the face of the geometry that help Maya figure out the direction of light. Well, if you look right here, you can see this is the normal. So this is, Maya is reading this as this is the outside of the object, and therefore this side receives light. Here's a face right next to it, but it's saying that this is the outside of the object, and this needs to receive light. So the problem we're running into is 2 faces are right next to each other, and they have opposite normals, and that can't be. You need to have the outside on the outside and the inside on the inside, and they can't be right next to each other. That's a great question. Often what's happening there is, in order to make that happen, is we get errors in extrusion sometimes. When you are modeling, not using best practices, sometimes your normals will get flipped on you. Like literally they just flip. And it's very frustrating, obviously, because, again, based on the math of how Maya's tools work, if you've got opposite faces next to each other, you're going to get some very bizarre iterations from your tools as well in terms of their function. So, again, there's a lot of things that spring from poor quality geometry in terms of problems for not only the modeler, but further down the production pipeline as well. So we try to nip all that stuff in the bud early on, fix everything we can. And the good news is, like I said, if you model the way we're showing you guys how to do it, very little of this comes up. And, you know, typically you see more of this stuff early when you're not as good at what you're doing, but later it's almost a non-issue. Very, very rarely do you have that kind of thing happen. But good that you know what it is so that you can fix it. That's a good question. Faces with 0 surface area. This is another naughty no-no. When you look at a piece of geometry and you go into face mode, you'll see these little blue dots here in the middle of the face. And that's where they should be, indicating that this is a face of geometry. But if you ever look at your geometry and you see those little blue dots and it's on an edge, what that's telling you is that there's a face in there, but it is so thin that it occupies the surface area of an edge. So it's in there, it's just squashed as flat as it can be. And if you literally grab the vertex and move it up, you would see the face trapped inside. So again, in terms of lighting issues and in terms of tools not working right, when you've got these extra faces inside your geometry, it can lead to problems. So, and for those, we typically just delete them or merge the vertices to fix it. So it's not a huge problem, but you need to recognize it for what it is. Otherwise, you're like, I don't understand why it's not working properly. Why are my tools not doing what they need to do? So you want to avoid faces with 0 surface area. And again, the good news is we have the cleanup tool to help us find these problems. Yay! Because they're very hard to spot sometimes. but you have to know what you're looking for, and you have to know how to fix it. And those are the keys. So now that you know what you're looking for, I'm going to show you how to use the tool to find the problems, and then I'll show you all the fixes for the various issues that you will be looking for. But the most important thing when it comes to the cleanup tool is that you realize that you want the tool to show you the problems. Don't ask the tool to fix the problems for you, because there is an option where you click on Fix It For Me, Maya. But Maya is not a modeler. Maya is not an artist. So Maya is going to do probably whatever Maya wants to do, and that's not exactly what you want out of the geometry. Does that make sense? Because Maya will, you know, it's like asking a 3-year-old to do something or a 5-year-old to do something. They're going to go shortest distance A to B and could care less, you know. Could you put those in the sink? Yeah, sure. Just go on, you know. So bear in mind, very, very seldom do I say let Maya have its way with whatever it is you're doing. But show me where the problem is so I can fix it. All good. So just make sure that you are doing the fixing. So if you go to Mesh and you get down here under Optimize, you'll see the cleanup tool. It's hidden down under there. And again, the big ticket item is make sure you're not asking Maya to fix anything. You just want Maya to show you the problem, not fix it. All right, so we're going to practice fixing some bad geometry. And what I'm going to do is demonstrate for you, again, the different illnesses we talked about, and then show you the little fixes for them. So you should be able to do that. In terms of this activity, this is actually your skill check, because we're going to finish it up as a skill check. So please set your project to your skill check folder, File, Set Project, and then this time, again, choose your skill check files. And then File, Open Scene, and you will see the cleanup project. Dun, dun, dun. Okay. So we've got this really cool blaster. You might recognize it as the Han Solo blaster. And what I would like you to really sort of take away from this is, wow, this looks like a great looking gun. Somebody did an awesome job modeling this, but it is riddled with problems. So no matter how pretty it is, it can have issues that need to be fixed. So what we've done is we've taken all of the issues and put them on different layers. So if you see, there's a whole bunch of layers over here, and they each have names next to the various issues that the geometry exhibits. So what I'm going to do is I'm going to go to the visibility column here where the V is and click it with my left mouse button. And I'm just going to turn all these layers off in terms of their visibility and hide everything. And then what I can do is bring back the geometry one at a time so I can isolate what it is I'm looking for. It'll make my job easier. So first things first, I'm going to go up to the top, n-gons. We talked about that as spaces that have more than 4 sides. So I'm going to activate that layer, and this piece of geometry has n-gons on it. All right? Now if you look carefully, you can see, yeah, that's going to be an n-gon for sure. That's got more than 4 sides. And typically what happens, again, is either errors during extrusion, using the multi-cut tool recklessly, or accidentally deleting edges. You know, all these things can lead to problems. But let's just say I don't know that that's an n-gon, one of the many I'm looking for. So in terms of the use of the tool, it works like this. Select the geometry with your left mouse button in object mode. Got to be in object mode, got to be selected. Next, if you go to Mesh, you'll see Cleanup towards the bottom of the Mesh attribute there. And Maya defaults to Clean Up, but that's not what you want. You want to make sure you choose Select. So make sure you switch that. That's very important. Now, in terms of selection, you'll see there's a list of a whole bunch of things, you know, problems that could be wrong with your geometry. So what you want to do is uncheck everything in terms of what it's looking for, and then just turn on the things you're looking for one at a time. Because the problem is, if you tell Maya to find all of the problems, they'll all light up and you won't know which face has what problem. It'll make no sense. So you have to narrow it down to what you're actually looking for. So I want four-sided faces on my model, right? So if I select, I just hit apply, Maya will select every face on my model that has four sides. And if you remember, that's my goal. That's what I want, if I can do that. So all these faces are selected. If I hit delete, whatever's left is the geometry that needs some attention. Does that make sense? So I can see I got some triangles in here, I got some triangles up there. But again, we talked about triangles aren't so bad. This is a problem though. Does that make sense? And the reason I chose use four-sided faces as my search engine, as it were, is because most of my models should have four-sided faces on it. So I'm trying to eliminate what's okay so that I have what's in front of me is what needs attention. And the most important thing is make sure once you've identified which areas need help, please, I beg you, hit Z for undo so your geometry comes back. Don't forget. You want that geometry back. Don't delete it and then start working and fix that face. And then you try to Z back to where the geometry reappears. So I've identified that this is my problem geometry, and now I can start moving forward to fix it. Yes, Derek, go ahead. Make sure you have your channel box selected, because if the channel box isn't open, you're not going to see the layers, because that's the only area where those are. Yeah, no worries. All right, so here is the problem geometry. It's obviously an n-gon. What tool have we recently learned about that is great for fixing n-gons? I'm gonna have to use vertices, definitely, but what tool? You guys remember? Multi-cut. Oh, that's right. Multi-cut is the tool that's great for fixing n-gons. So what I'm going to do is go to Mesh Tools and get my multi-cut tool out. And basically what I'm going to be doing is kind of like trying to reconnect these things to each other. So I'm going to click into the middle of the edge, drag until it hangs up on the corner. Go to the other side, click and drag until it hangs up on the corner. And now that it's in there, hit enter, and it's going to cut that in. I'm going to get that tool out again. Mesh Tools, multi-cut, click and drag, hit enter. Get that tool out again. Multi-cut, click and drag, and then hit enter. Come down here again. Get that tool out. Click and drag, and hit enter. And you can see it's already turning these into four-sided faces. I'm fixing these guys down here. But some of these guys up here still need some attention. So get my multi-cut out. Click and drag, hit enter. Get my multi-cut out, click and drag, and hit enter. And then get that tool out one more time. Oops. Multi-cut, click and drag, and I can go all the way down to here, and you'll notice it'll put in points on those other edges. Hit enter. And then now, everything's got four sides on it, and I can check it by selecting it and using my cleanup tool. Look for four-sided faces, run it. Those faces are selected. So if I hit delete, oh yeah, what's left? I got some triangles in there, but we talked about triangles are okay. But if I had to fix those, I could use the multi-cut to do that. So I hit Z to bring my geometry back. Please do that. And now this has been cleaned up in terms of n-gons. Does that make sense? Yeah, hell yeah on that? Okay, good. So now we've got n-gons out of the way, so I'm going to hide that. Let's take a look at floating vertices. Now this one is a tough one because you might be looking for n-gons, right? You got four-sided faces in there. And if you look at this, that looks awesome. That looks like every face on there's got four sides. There's nothing wrong with this thing. So if I run it, I'd be totally confused by the fact that Maya says there's something wrong with all of this geometry. It looks okay to me. So what I'm going to do is get a little bit closer look. Let's do an inspection. And what I'm going to do is go into vertex mode. And if I go to vertex mode, this is where I start to see the problem. These vertices here. Are those vertices connected to each other? What do you think, guys? No? Now, it's true they're connected to each other this way, but they need to be connected to each other in different ways as well. These need to be connected to each other. What's the ailment we talked about that this is? What is the polygon illness that this is exhibiting? The unsupported vertices, right? So the problem here is these vertices are not properly connected. These vertices are. Do you see how that looks different? Okay. So here's the thing. The good news is unsupported vertices are a very easy fix. If you select them, you hit delete, they're gone because they're unsupported vertices. They're not properly connected, therefore they can be deleted. Now you might be worried, oh no, what happens if I select vertices that are supported as well as unsupported? What happens? If I hit delete, only the unsupported ones go away. Vertices that are properly connected to each other cannot be deleted. You can't just select vertices and hit delete and they go away. Not possible. So here's the problem though. There is always a rub. Let's say, for example, this is what my model looks like, right? I need that little bump in the middle there. If I delete these vertices, it changes the shape of the polygon. Does that make sense? So what you have to ask yourself is, when it comes to these unsupported vertices and the n-gon they create, if I need this detail, I'm going to have to connect the vertices to each other. If I don't need this detail, I can just delete it and the problem is solved. But if I do need this shape, if I do need that exact shape, I'm literally going to have to come in here. And what tool am I going to use to connect those to each other? Multi-cut, exactly. It's great for that. Mesh tools, multi-cut. And again, I'm just going to click and mesh tools, multi-cut. And I'm just going to click and drag. It's starting to act a little nutty on me. Multi-cut, go there, go there, go there, go there, hit enter. Now they're connected. Does that make sense? Okay. So again, and then I have to run one down there as well to make that four-sided. So some vertices that are unsupported you can just delete and get rid of. Others you have to actually connect them back together. That's a great question, because I get that one a lot. Students will say, well, I want that edge to go all the way around, right? Why not use the insert edge loop, because that's what that does. Let me undo this to get it back to where it was. Mesh tools, insert edge loop. Huh. Not working. Why isn't it working? Does anybody know? Anybody? No thoughts? It has to do with that. It's not necessarily the shape specifically that's causing the problem, but the fact that the faces are n-gons is causing the problem, because the insert edge loop tool will not cut faces with more than 4 sides, and it cuts faces with fewer than 4 sides in an unusual way. Sort of tries to connect them to each other. So the issue you're running into is that tool literally will not cut those faces at all. And that's why the insert edge loop tool is not the best one for fixing n-gons and the like. Really, the multi-cut is, because that's one of the few tools that will allow you to cut non-4-sided faces in any way you want to try to make it good in terms of mathematically sound. Does that make sense? But I get that question every month. Why not insert edge loop? And that would be great if the insert edge loop tool worked like that. It doesn't. We got to go in there and actually fix that. All right. So again, the floating vertices is a problem. normals being backwards or flipped is pretty obvious when you see it, because usually the geometry has a crazy dark color to it to tell you it's not good. But something that you can do to verify the issue is you can actually ask the normals to be visible, because by default they're not. If you go to display, polygons, face normals, you can actually turn on the normals, and basically what you see are these little green spiky things sticking out of the geometry. It kind of looks like a cactus. And you know, if you're looking at this, you're going, hey, but Steve, you said that when they're facing the right way, they stick to the outside. But what's going on here is if you go inside the geometry, you can see they're sticking from the outside of the object, or what should be the outside, through to the other side, and that's why it looks like that. If you go inside here, this is what should be the outside of the object, but it's the inside. And this is the inside, but it's the outside. So the good news is this is actually a super easy fix. You just go to Mesh Display and choose Reverse. And what that's going to do is flip the normals around so that they're facing the right way. And you know they're the right way because they're a nice gray color, and you've got all of these green indicators sticking on the outside like a cactus, and you see they're longer. And when you go inside, you'll see there's hardly any on the inside. And that's what you want. You want all the normals on the outside, indicating that the geometry is facing the correct direction and it's being lit properly. And again, in terms of getting rid of those normals, it's the same way as the way you turn them on. You can't just let go, because if you select it, they're back on again. So what you have to do is go to Display, Polygons, and then go to Face Normals, and then that turns them off. And again, an easy fix, just select the geometry, Mesh Display, Reverse, all better. Make sense? Okay. So that's flips normals. Non-planar faces, let's take a look at that one. Okay. Now, in terms of a cylinder, let me just make a cylinder so you can see one. Do you see how when I'm looking at a normal cylinder, I can see the edge on either side of this object? There's a bright green edge to define it in terms of its surface. You guys see that up on my screen? All right, I can see the green over here, and I can see the green over here. Now, if I take a look at this face here, do you see how there are areas where I don't see the green on the edge? Do you see how the gray of the object just sort of blends into the gray of the background? Does that make sense? Okay, what's happening is these faces have too much torsion on them. They're twisted somewhat, and I'm creating a change in shape that my edges are not supporting. And this is actually a very easy fix. All you have to do is grab the vertices in question and literally turn them, and then you see, oh, there's now my geometry has edges on the edges. It doesn't leave off with green, with gray. It actually, I can see that transition from geometry to background. So it's pretty easy to take that twist or torsion out of the geometry just by moving the vertices. All right, double extrude. You guys remember me talking about those little blue dots that indicate a face on your geometry? Well, here's the problem. Do you see how this edge has a dot on it? And you see how this edge has a dot on it and that has a dot on it? Those are faces with zero surface area, an accidental double extrusion. Now, to look at it, you'd say there's nothing wrong there. But watch what happens. All I have to do is select a face and use my Move tool. And I'm not extruding or anything. I've just grabbed a face and I'm using my Move tool. And if I pull it, there's a face inside there. And you see, oh boy, that's not good. Because if this was like a face that didn't have a problem, if I grab a face and move it, you see how all the geometry around it moves? It stretches out. versus what happened here, which looks like I did an extrusion. Now, another way to see faces in between faces is, again, in terms of component modes, we've gone to vertice, edge, and face. You'll notice that there's something called vertex space. And vertex space is a component level that allows you to see all the faces of your model. It just kind of separates them a little bit, but it's just visual. And then you haven't really blown up your model. But it takes every face and kind of spreads it out a little bit. And if you do that, what you'll see is there are little lines in between the faces where there's a face that has no surface area to it whatsoever. And again, that's obviously going to cause problems with lighting. That's obviously going to cause problems with my tools. So what I'm going to want to do is fix that. And again, I want you to note that there's little faces in there, and you can see when I grab them, you know, this is, my geometry should not be doing that. So the good news is it's actually very easy to fix that kind of issue. What I'm going to do is merge my vertices. And merging your vertices is basically taking two vertices, because if I look at this situation here, I've got two in the same place. I'm going to take those vertices and glue them together so they become one vertice. And vertice merger, the most important aspect of vertice merger is what we call threshold. And threshold talks about distance. That's what that's all about. So let's say, for example, Brian is a vertice, I'm a vertice, and you're a vertice, right? And a happy vertice at that. If Brian and I are 1 unit apart, 1 grid unit in Maya, and you and I are 3 grid units apart, he's a greater threshold than me, further away, right? 1, 3. So if I select you, and me, and I try to merge us with a threshold distance of 1, Brian and I will become one vertice. You will be unaffected. You were selected, but you are outside of that 1 grid unit threshold because you are 3 grid units away. So if I select you, me, and you, and I set it for 3, we all become one vertice. Does that make sense? So think of threshold like proximity. And the numbers are grid units, distance. So the way this works is, if I want to glue some vertices together, I can literally grab the vertices, and then under Edit Mesh, you will see there's a tool called Merge. And of course, I'm going to go to its Options box. And the Options box for Merge, again, you'll see there's threshold in there. Let's say my threshold is too high. Let's say I'll set it for like 5, right? So everything within 5 grid units will merge. So if I merge these guys, you can see kind of like they all got sucked into a black hole. Everything that I had selected merged into one vertice, and it creates some serious mayhem in terms of my geometry. But if I make my threshold a very small distance, like 0.001, what I'm saying is only vertices that are virtually right on top of each other will glue together. Even ones that are very close will not. They have to be on top of each other to glue together. So then with that very small threshold, if I hit it, you'd be thinking, oh, shoot, it didn't do anything. But if you look at my model, do you see I don't have those dots on the edges anymore? They're gone. And if I select a face and move it, that's the way it should be behaving, not like an extrusion. That's what the geometry should be doing. Does that make sense? Hell yeah? Okay. So again, that's the merger. And then that will help fix the double extrude issue. Now, interior faces, the issue here is I've got geometry inside my geometry that I don't really need. And sometimes this is kind of hard to spot. So what I'll do is I'll go into shaded mode and choose X-ray. And I can see, if you look at your geometry, do you see that dark shaded layer in the middle of that piece of geometry? That is geometry inside my geometry that I don't really need. You know, I need this detail on the top because that's That's kind of a fun little detail in there. You know, this is some kind of top of a nut or something. But I don't really need this additional geometry on the inside, which again I can see when I'm in X-ray mode. I got this extra layer in the middle. So what I'm going to do is I'm actually just going to come inside here and I can just delete this stuff. So I'm going to go to face mode and I can select the faces and just delete them. And I want to get rid of all the ones on the inside. Make this thing nice and hollow, like a chocolate bunny. And I'll put it under shaded mode again so you can see. See how it's nice and hollow in there now? I don't have that extra little floor of shading in there. Don't need those faces. They're not doing anything for my model. So get rid of them. All right. Now, here's where we get to the skill check. And here, I'll bring up your little skill check so you can see it. All right, here's where we get to the skill check. Your skill check is using this same file. You'll notice that there's a layer called Problem Hunt 1. Now, Problem Hunt 1 is a big piece of this gun. It's got problems on it, a bunch of them. I don't tell you which problems are on there. It's just there are several. So what you can do is go through the different layers, starting with n-gons, and work your way down to interior faces, which was the last thing we fixed, and just practice fixing those problems. Then turn on the layer that's called Problem Hunt 1 and make sure everything else is turned off. And what I want you to do is then use the cleanup tool in Maya to try to find problems and fix them. So what's going to happen is when we look at that skill check, we're going to open up your file and see were you able to find and fix the problems with the geometry. Does that make sense? So we're looking for n-gons, we're looking for unsupported vertices, we're looking for non-manifold geometry, we're looking for interior faces. All of those issues that we just spoke of can be exhibited in this piece of the gun. So you got to figure out where the problems are and then fix them. Again, mostly with the multi-cut tool for most of the issues, except instances where the normals are backwards, in which case you'd be using the reverse of the mesh display. Does that make sense? Okay, so what we're going to do is we're going to get started on this activity. Brian and I are going to walk around a little bit, this skill check, and Brian and I are going to walk around a little bit and just make sure you've got the hang of how this tool works and looking for and fixing problems. And then that's actually all of the material I want to talk about today. We won't delve into anything else. But I will close by saying make sure you give yourself plenty of time with your turn-in. We have 4 weekly turn-ins, and they're worth a lot of points. You want to get as many as you can. This is the easiest of the turn-ins we're going to do. So make sure you get as many points as you can, because that's only going to help your average. And again, the things that we talk about in class are the things that are in the self-grade document, and coincidentally, no, the things we're grading you on. So make sure you're familiar with those things. Alrighty? So again, Brian and I are going to walk around now. My digital friends, I will see you guys on Wednesday, but I just want to make sure that everybody can use the cleanup tool before you run off to use the cleanup tool all afternoon long, because I know you're just dying to play with this thing. So thank you very much, everybody. And again, Brian and I are going to walk around and see how we're doing with the cleanup tool on this little piece of geometry. And again, you want to make sure that in Maya you have turned on your Problem Hunt 1 piece of geometry, which is this bad boy right here. And I'm going to put it back into regular mode so I can see the geometry. And you can see there's a couple of pieces of geometry here, and it's got problems, and we got to fix them all. So you want to select each piece in object mode and then use the cleanup tool to find out what's wrong by selecting the different things that you could be possibly looking for. Alrighty, so let's see how we're doing. Let's go, Brian.